So now, I've been using the photodiode in recent videos. I figured I would use it in the 555 timer circuit as well. There you can see, we have a low output unless it's dark enough, then we have a high output. So we will look at why. We have pin 6, the threshold pin, to the negative supply so that it doesn't do anything, although it's weaker than the trigger pin, so we probably don't need to do anything with it. We got the trigger pin, pin 2, to the negative supply. It's telling the output to be high, but the output's not high right now. The reason why is because reset pin is more powerful. And we got the photodiode there, it's reverse bias. That's the cathode up there, the shorter lead, longer lead, the anode down to ground. We have a 100,000 ohm resistor to help raise the voltage there. But in any case, we got light falling on this. It's connecting to ground pretty good. We get it dark enough, now we don't have a low input to the reset pin. So the trigger pin can set the output high and the red LED lights up. So now, here's our schematic diagram where the output is determined by the photodiode right here. So we'll look at why coming up. When the output's high, the red LED lights up. We got that current path, although we lose some voltage in the process. When the output's low, the blue LED lights up. Pretty straightforward. Pretty good connection to ground. Pin 6, the threshold pin, it's waiting for a high enough voltage. You put it to ground, it doesn't do anything, although it's a weak input, so probably wouldn't do anything anyways. Pin 2, we connect that to ground. So pin 2 wants to always set the output high. That's what it wants to do. Pin 4 is the reset pin. That's the more powerful pin. So we got light on the photodiode. That pulls the voltage down. You know, not quite as good with that pull-up resistor there, but still does a pretty good job. Any amount of light pretty much pulls it down. Reset, that sets the output low right there. We get it dark, then we got a high input. It doesn't do anything.